of course. So think about that again. We're going to draw. And what you're going to find, like I said, we're going to practice this in a minute on a Nearpod. But what you're going to find is that you kind of can tend to draw the curve a little bit better either on the left or on the right to help see it. So that's why my suggestion is that you practice with drawing this on both sides of the curve until you kind of see where that change of curvature is. So here's the tendency. The tendency is to just think, okay, here's my mean, and if I kind of think about the particular length here, and I look at like where the middle of that distance is, and you draw from there, that's kind of the tendency that people do. But guys, that's not where the standard deviation is. The standard deviation is going to be a little bit higher than that particular place. So I'm going to erase, and I want you to kind of look at that again, and we'll talk about this particular curve in a second. But let's talk about these up here. So we want to draw in our mean, and then from there we want to draw in, kind of try to draw in the shape of the parabola that would open down, and then draw going from each other direction. So from here, think about how you would draw this parabola going up. Oh my gosh, my iPad is just not cooperating today. And then you're looking for where that point of intersection is. And quite honestly, I mean, if you're going to be technical, I found point of intersection here, over there. I found it here, there. In my opinion, this is a better drawing of it. So here's where my standard deviation is. So I'm going to want to see, when you draw in your standard deviation, you can either use a lowercase sigma or you can use an S. When you draw that in, you want to draw from a point on the outer curve to where the mean is. That's how you draw your standard deviation. Okay?
I get it, actually.
All right, so last one here, we're drawing mean first. Think about kind of drawing your curve. You definitely want to do this with pencil and not pen, because you might have to kind of go back and redraw that. And then draw in that, I bumped when I was doing that one. Let me see here. That one's not so good either. I would say that standard deviation's about right there on that curve. We're going to practice in just a second on a Nearpod, so we'll get to that in just a second. Let's look at this example, though. It says the heights and feet of fully grown white oak trees are normally distributed. Normal curve shown below represents this distribution. What is the mean height of a fully grown white oak tree? Guys, what's the mean? The mean is about 90. It's not exactly at 90 feet. But then it's asking, estimate what the standard deviation is. So try to draw in your change of curvature there and figure out what's the distance there. How many feet is the standard deviation? What would you say, approximately? It's not 5. It's less than 5. I would say it's actually closer to 3. So your standard deviation for this set is about right there on that one. So standard deviation is about 3 feet. So that's what you have to kind of be careful about, is that if you go too far out, it's not going to be very accurate in terms of what you're saying for standard deviation. Okay? All right, I want to practice that a little bit, so let's grab your laptops. I want to do this Nearpod, and then we'll get back and we're going to talk about the empirical rule. Most textbooks refer to this as the empirical rule. Some textbooks, like the one we use, literally just calls it by the numbers that you need to get memorized. And you're going to need to get memorized a few different sets of numbers. So the 68, 95, 99.7 is one set of numbers that you need to get memorized. The other set we'll look at here in just a second. Okay, Malbec, Jonah, Tristan, I need your attention. Yep. Okay. So the amazing thing about the empirical rule is,
Do you get it, Owen?
She hasn't explained it.
the amazing thing about the empirical rule is these are just approximate numbers. These are just approximate values that are used that somebody kind of discovered along the way. But they are really, really pretty accurate compared to what we would find on an actual table of values, okay? So keep that in mind, please. Okay, I'm going to draw a picture here. We're going to talk about this over here, but I don't want to color in too much on this. Actually, this is what I draw it on this other page because I have more space. Okay, I need you to think about this. When we start drawing these normal curves and doing computation on these curves, we're not going to be as precise about finding exactly where the change of curvature is like we were just doing, but we're just putting in hash marks to show our 3 standard deviations above the mean, 3 standard deviations below the mean.
Is Willing supposed to be in this class right now? Why does it matter?
Don't worry about it.
He's right there.
Okay,
Wait, what?
so guys,
Where is he at?
if 68% of the data is in this particular interval, then if we're looking at the 2 separate slices, if we're looking from the mean up to 1 standard deviation above the mean, what percent is that data?
Oh, that is 68%.
No, it's not.
That is 97%.
It's 95.
Okay, if this whole thing here is 68, then what did I just color in?
34%.
Thank you very much. We have to take half of it. This is 34%. That means this is 34%. We're just dividing that by 2, right?
I want to make a big one.
Okay, so you need to memorize that slice of 34%. Guys, that's it's a little more than a third of the data values are from the mean up to 1 standard deviation above the mean, right? Think about that for a minute. Okay, think about the fact that empirical rule tells us 95% of the data is in this interval, right? But if we want to consider how much is just in the blue that I am shading and not that purple that I've colored, right? Then we need to do some subtraction here. We need to say 95 minus 68 to figure out what that is. Yep, and we get 27. We've got to divide that by 2.
13.5.
So yeah, that means each of these slices here is 13.5%. You're going to have to remember that, not just the 68, 95, 99.7, but you need to have memorized the 34, 13.5, and then these others also, okay? Think about the fact that we know this full amount, those 2 slices together on each end, are 2.5%. That's helpful to know, but we also need to break it down into the two parts, right? So those last 2 parts together is the 2.5%. But let's do the math again. If we do 99.7 minus 95, then we get 4.7, right? And then if we divide this by 2, yes, good. We get that this part of the slice is 2.35%, and this part of the slice is 0.15%. Okay, so besides the 68, 95, 99.7, you need to get these slices memorized, and they are 34, 13.5, 2.35, and 0.15. Okay? Okay. Questions on that?
We should do Kahoot to really
Now
lock
let's
in.
see, well, we might. If we have time and I can find one, we will. But I want to do just a couple practice problems just so that you see how we use this. Okay? Okay, think about those slices I'm going to do. We're going to talk about this first, and then I'll go back and I'll draw another curve over here. So what the empirical rule tells us is that 68% of the data in a normal curve lies within, if you notice the way it's written here, it says approximately 68% of the observations fall within 1 standard deviation of the mean. So what that means is that we're talking 1 standard deviation above and below the mean. So That's right at the mean, right at the 0 on your paper, okay? And if we go 1 standard deviation to the left and 1 standard deviation to the right, 68% of the data is in this particular area right here, okay? 95% of the data lies within 2 standard deviations of the mean. And that means we're talking from the mean, we're going out 2 standard deviations in both directions. And so it's all of that area that I've drawn in the pink. It's 95% of the data. So guys, think about that for a second. That means outside of that area is only 5% of the information, right? So that means here is 2.5%, and here is 2.5%. And we're gonna break that down into the smaller little categories. You're gonna need to know those numbers also, but think about that. So what that's telling us is that for 95%, that 95%, 2 standard deviations above and below the mean, above and below.
Like it's not sharing.
Whoops, I'm sorry. Thank you. Why didn't you say something sooner, for heaven's sake? Here I'm coloring and drawing.
I don't think Owen was paying attention.
Well, okay, don't even go there because you weren't either, Jonas, so don't even go there. Okay. So, let's go back then. The purple here, that is 68% of the data is in this particular area, right? 1 standard deviation above and below the mean. 95% is within 2 standard deviations above and below the mean. So that's the pink, right? And then that means that we have the 2.5% outside, beyond 2 standard deviations from the mean. Okay, so if you are beyond 2 standard deviations in both directions from the mean, beyond 2 standard deviations from mean, those values are what's considered unusual, okay? Within 2 standard deviations of the mean, that is considered usual. So from 2 standard deviations below the mean up to 2 standard deviations above the mean, that is considered usual or typical. So from 2 standard deviations below the mean all the way up to 2 standard deviations above the mean. That's 95% of the data. That's the majority of the data, okay? All right, the empirical rule takes us out one more time, and that is if we go 3 standard deviations above and below the mean, so that's this green here, notice it's saying 99.7% of the data is in that particular interval. 99.7, so not quite everything, but almost everything, okay? We're gonna break down these categories because you need to have memorized the 68, 95, 99.7, but you also need to have memorized what each of these individual slices is, okay? So let's go back. Okay. Here's the other thing to notice. There's kind of a notation that is used that's understood. So if you notice, it says, according to Health and Nutrition Examination Study, the heights in inches of adult men are, here's this notation. The N means that we're talking normal curve. So normal density curve. The first number, so in this case, the 70 is our mean. So the first number is always our mean. Second number is always our standard deviation. So in this case, our standard deviation is 2.8. Okay?
So how does that help us?
So yeah, that helps us because we're going to label this curve with these values. So if our mean is at 70, then that means we're putting 70 here. And that means to show what each of these particular values is, because we kind of want to think about this as if it's on a number line here. We want to add 2.8 and add it again and add it again. So we get that this would be at 72.8. This would be at 75.6. This would be at 78.4. And then similarly, if we do 70 minus 2.8, and then minus 2.8 again, and then minus 2.8 again. Okay? All right. Now, think about what this is asking. I'm kind of just gonna highlight some of this for right now, and then we'll talk about the values that we get. So if you notice, it says, what proportion of men are less than 67.2 inches tall? So guys, that would mean we are from here and over all of this.
Oh, that means that it's the second deviation.
No, that's one standard deviation below the mean, right?
So that means that it's
So we have to look at each of those slices, right? So, yep, we're doing 13.5, that's this slice, plus how much else? That's 2.35, plus
70.
that, what is that small little tail at the end? 0.15. So we need to add all of that together. What does that give us? 13 point, so 15, blah, 15 point,
It's just 16.
yeah, it is just 16, isn't it?
So 60%.
Okay, back up.
Oh,
Yep, so 16%.
Oh, we're so good at it.
All right.
Yeah, we are.
Actually, that makes sense, because think about this another way. Another way we could have figured this out is what percent of the data is going to be from here over, right? How much is this?
80.
What percent?
80 something.
From the mean up to the top?
84.
no.
Guys, from the mean to the top is what percent of the data?
50.
50, thank you, Malbec. Plus this, which would be 34,
That'd be 80.
so that would be 84, and if we do 100 minus 84, we would get the 16. Jonah, you need to focus and concentrate.
Sorry.
Okay, what percent, I'm going to erase all of this. Okay, what percent or what proportion, it can be worded, that's part of it too, is you're going to see this worded a whole bunch of different ways. So what proportion of men are less than 75.6 inches tall? So that's from here and over, all of this.
So that means
So we're talking 50,
97.5.
Plus- good. We're
Yes.
talking 50 plus 34 plus 13.5, so yes, exactly, 97.5%.
2.5 minus.
Yep, you could have done that as well, right? 100 minus
I'm not doing
2.5.
Well, then wouldn't the next one just be 2.5?
We haven't gotten to the next one.
So yeah, if it's greater than 75.6, then that is the 2.5%.
You spoiled it.
Oh, it's 2.5.
Okay. And then last one,
Oh, this is a hard one.
No, it's not.
78.
Where's 62.7?
There you go.
I actually did right.
okay. So what proportion of men are between 67.2 and 75.6?
81.5.
Yep. So this is 68, or you can think of it as 34 plus 13.5, either way you want to think about that. But then ultimately, yes, we get 81.5%. Excelente.
I had 1.8.
Okay.
So the ending.
You just got to remember, you got to memorize those numbers, right? It's pretty straightforward and easy. I've got worksheet for you. I will get you that. You probably could even get the whole thing done if you wanted to before you even had to leave here.
Tomorrow.